And let me know when you can see.
Yes.
Excellent. So, interesting paper, very interesting approach. I hope people got a chance to read it. Haven't read a ton from OpenAI, and I thought what they're trying to do with this is, yeah, a very interesting approach to way to get around some of the distributions in a couple different ways. So, let's jump right in. What we'll cover the problem. Do our evals predict real deployment? Um, and there are a couple ways to take that and how they're trying to get a better place in that, simulate deployment by replaying real chats. And findings at a glance, we'll go through that and on a scorecard. There was a correction that was made about the second uh, pre-registered hypothesis, and then the what's durable, bound, especially around evaluation awareness, and then some critiques, implications, and some discussion, and then we'll jump into the discussion amongst all of us. So the problems are that we depend on pre-release evals, and they're a combination of what we do. If you've been in this group and others, you'll know that there are many challenges trying to even get faithfulness. There are many approaches um, that make it difficult, whether it's chain of thought monitoring not succeeding, sometimes possibly even linear probes not succeeding at what we think they will. So there are a number of challenges, and we'll go into that a bit more. But they often miss how the model behaves in the wild. And as the models have increased in capacity, capabilities, they are almost all the time aware that they're in evaluation. So this is really some important work, and I don't know of this approach being done anywhere else. So if they're miscalibrated, then the safety case is miscalibrated too. So we have coverage, representativeness, and that's really what we're focusing on here, and then being recognized as a test. So we'll go into more about what the results were, but their main approach is to attack the distribution. So most of the evals that we're used to seeing have very crafted prompts. Some of them maliciously like crafted within what would seem like human distribution, but they're not just a user expose them. So they're far away from the normal distribution, and whether it's that or other factors, tips off the models, and we don't actually know how they're going to behave in the wild. So go into the next. So first off, as the quote says, we started with de-identifying conversations. These were from data set that they have internally. They did not release this. So that's one challenge about this because it's not replicable outside. But it was for conversations that they had permission to work with, and then they also de-identified them. And so they hold those fixed initial conversation prefix and then regenerated the next response and using the candidate model. And so it's that one pair that they're really looking at. And so you can see in the diagram how they're actually doing it. They're finding the conversation prefixes, they're resampling against the candidate model, they're doing automated audit, trying to note bad new behaviors, um, and then updating their tracking, grading, and then estimating, and then comparing to post-launch. They also did this retroactively for previous models so that they could have more data. So on the left, we go into a bit more detail, but in the aggregate, they had 700,000 new turns and across 20 misbehavior categories. There was a bit different behaviors or findings in some of the categories. And we'll go into that some more. So top level findings. So one great thing about this study is that they actually pre-registered their hypotheses. That's not happening in most papers and most studies, but they did it. I think probably partially because otherwise there's no way to check their work or say, great, how many times did you run it? So they did pre-register. They believed that all these hypotheses would be proven. Turns out when they first started analyzing it, the first hypothesis was not proven. And then that was to just, would it beat a naive previous rate baseline? So if you're coming out with ChatGPT 5.4 and you say it, if you just extrapolate from what the behavior was in 5.3, would that get plus or minus the same as this approach? And it turns out it didn't get it. So that failed right off the bat. They thought that there was some support for their second hypothesis was to beat the challenging prompts. So that's the kind of evals that we're used to seeing. But after they did some final corrections, the p-value was 0.047. And they do note it. They don't highlight it extremely, but they do note that it's not confirmatory. So it's not proven. So it really fell down to their third hypothesis, which was quite a simple one, that whether there was no novel misbehavior. And there was support not found for that because there was a calculator hacking that didn't get caught. I will note, and I think we have it somewhere else, that it did find an instance that was missed in a previous release. So it does have some utility, but not what they had hoped for. So there are a number of graphs. We'll see they're quite in depth. I try to make them visible and also not to go into too many of them, but we're not going to go into all of the details. And hopefully you at least take this as, here are some of the charts that if you didn't get a look at the paper yet, that you can dig into them as well. So quote was that a traditional alignment evaluation shows evaluation awareness signals roughly 2 to 3 orders of magnitude more often than production traffic. Now, of course, if you're handcrafting or in an automated way, crafting prompts that you think will elicit some negative behavior, misaligned behavior, then that's obviously what you're doing. However, it gives us quite distorted view. I'll cut to the end and then come back. It seems that probably the best approach will be do something like this where you have an idea of its real distribution, and then doing some red teaming prompts so that you get those very rare occurrences and see how they do. So as you can see, you have evaluation detection capability, verbalized alignment evaluation awareness, and metagaming reasoning. So there's good drop off. I think there's another graph later where one thing that this did prove is that it basically was even a little bit more, it appeared to be production a bit more than production did, which is, there's a little technical reason why it's even more. But the verbalized alignment eval awareness was tiny, minuscule. So 0.018% versus up to 26.8% with the red teamed prompts. So that's huge. And this is something that we've seen papers here and elsewhere from Petrie, from the UK AI Safety Institute, trying to make harnesses that tip off the models. Here, one of the biggest ways that they're not tipping off the models is just the content. So it's forget about the API calls and how they're delivered or the timing. It's just the content, at least before we get to the agentic part. Um, so what tips the models off? So their format cues. For example, there's the exam style, produce a solution dot py text file as a result. There's some standard things that are really obvious, and frankly, we should be doing a better job at making them not quite so obvious. And then there are the scaffolding tells. Um, there have been some instances that I believe they've found that just the timing differences between what a real production instance does and what a scaffolding does is enough to tip off a model that's something that they're in an evaluation. And then, of course, this is a test um, and some other types of tells. Um, the bigger the model, the more modern the model, the more they're noticing. I think it was Opus 4.6, if I'm not mistaken, that Apollo Research had to decline to render any opinion. They only did have 3 days, but still, it was just so evaluation aware. They couldn't get valid data. And so they didn't say uh, that that was a positive or negative finding, just that they could not render one. So this is attacking a problem that's a real problem. So, big question is what they're trying to attack is, does this forecast, does it accurately indicate that a specific category is going to get worse, more misaligned or less misaligned, or it will have show signals of that. And so here you can see if you multiply the different aspects um, of the misalignment, you can see that it actually does help the directional accuracy the further it goes away. There's a chart later that shows this a little bit better, but it's about 84% all 24 categories. And one challenge is that you don't know which categories will move ahead of time. So one of the findings was yeah, we'll come to that graph, but the the further it is to the right, the further away it is from the previous sample, the more likely it is to correctly diagnose it, but you don't know the categories that will be far away from the previous model or not. So it's a dubious value or less forthright value. Here we pretty much came to it in their appendix table 1. The final hypothesis does not support H1, and the final H2 should not be described as confirmatory, even though the P was less than 0.05. We've already covered that. So how are we doing on time? I will skip through some of this. This is the chart that I was mentioning before. All the greens, if you can see them, are misaligned, and all the blue squares are disallowed content. And then the further they are to the top left, the more that this model has a higher production rate than it was the simulation estimated. So it was on average a bit more towards that. It did predict better when they're a bit closer, but yeah, there we can go. And the Gentic tool. So this was another novel thing. So there are a number of different aspects of this to cover. So I was a little worried that I'd be able to get them all in one. So one part that they did, which was totally separate than the rest, was how to simulate agentic activity. And so they had different types of affordances from none to a simulated database, a simulated container, and just the original conversation or a combination of these. So as you can see clearly, the more you put together, the more of a simulated environment that the agentic code had, uh, it gets up to almost 50%. So at 50% win rate, that means that the judge couldn't tell the difference. It was a coin toss. So it got up to 49.5. So basically even. So it was almost impossible to discriminate between the two. So honestly, even if I don't know of another paper that's done this, but just that finding is really useful, and all agentic um, eval should be using that going forward. Um, this so there's a wild chat, which is a public data set. I think the last used is, yeah, thank you for removing that. The last data I think is from 2024. Um, you could replicate it with this, but the error rate goes worse. So with the private logs that they have access to, it goes from like 1.75x, it goes a bit further out. It is able to replicate, but so that's good news for independent researchers, for safety institutes or security institutes, but it isn't it isn't as good as what we'd want to, and I covered that at the end. So here are some of my critical reads. One, the realism versus coverage are one property. Um, so low eval awareness and tailoring tail risk blindness are the same coin. So if people get that you're taking the distribution of all of the chats that were in this data set that they have, then that means by definition it's not going to be skewed for the hard-hitting red team tasks. In fact, some of them are, say, 1 in 10 million conversations. So in their 1 million conversations, it won't even appear. Or there's it's a 1 in 10 chance that even one of those appears. So you're not going to get the same coverage, but that's how that you get the eval awareness. In the discussion after, we can talk about some ideas I have about what you can do with that. But those aren't different things. They're really the same thing. And so another is that the lab owns the model, the ground truth, the graders, and the taxonomy. That's why it is important that they actually showed that you can replicate this with WildChat, which are public. But even with that, you won't have the chain of thought monitoring that they have. So that's a problem. Another thing that they didn't test was linear probes. They correctly note that there's likely going to be more and more of a legibility problem with chain of thought, because it's shown that that can be corrupted and avoided. But linear probes have a bit better chance and probably are going to be a little bit longer lived. So not sure why that they didn't check that, but they didn't. We've gone through most of this. They did not establish clean superiority of even the baseline. The baseline being if the previous model was at some level, then I'll predict that the current model is the same. Reality is there's not usually a huge change between models, like in a 0.1 release, but still that's kind of discouraging. And as I say in the bottom, it's best framed as here's some techniques that you can use and build on, but not use it to finalize a verdict. And here I think go into added them, but here I'm really going into my own speculation, so I want to keep that separate from what's in the paper itself. And so we'll call that the end, and we'll dive into the questions. And really